Okay, the next concept we're going to cover in this video lecture number 4 is operational definition. So that's the next critical concept related to measurement in science, and we've certainly talked about this already in class. Herbert Feigl, who was an Austrian philosopher, defined operational definition like this. To put it briefly, if crudely, operational analysis is to enable us to decide whether a given term in the way it is used has a cash value, i.e. factual reference. If it does have factual reference, operational analysis is to show us precisely what the factual reference is, in terms ultimately of the data of direct observation. Now here's a little briefer definition. Operational definitions are the links between the empirical or descriptive terms of our scientific language and the data of our experience. But my favorite definition is the one in green at the bottom of the slide. An operational definition defines something specifically by how the researcher chooses to measure it, moving from the abstract to the concrete. So one way to think about operational definition and this idea of moving from the abstract to the concrete is to actually contrast the idea of operational definition with the idea of conceptual definition, with a conceptual definition being just what it sounds like, a more abstract statement about the phenomenon you want to study. So in scientific research, this is often going to be the first concept or idea the researcher is thinking about. For example, hey, I think it would be interesting to look at the levels of violence exhibited by minors who watch violent video games. Or, I'd like to study the effect of intelligence on social adaptation. Or, I wonder if there are different educational outcomes in same-gender classrooms as compared to mixed-gender classrooms. All of those conceptual ideas of something you might want to study. So a researcher starts with one or more of these conceptual definitions, but both for the researcher to be clear with herself while designing her study, and of course for others to be able to understand and evaluate the research, she has to operationalize the abstract concepts. She has to come up with clear operational definitions of how she is defining her abstract ideas here for this particular research. Now, some things seem like they would be, and in fact they are, capable of only one operational definition. Something simple like jury size in jury research, for example. Jury size is just going to be a number. There's no need to move from abstract to concrete there. But again, where operational definition becomes critical is when there is this leap between conceptual definition and operational definition, when a researcher needs to take an abstract concept or non-observable concept in which she is primarily interested and make it concrete, which again not only allows other researchers to understand exactly what was looked at and how it was measured, but it also allows someone else to replicate a study. So this is something you should always look carefully at when you're reading about the results of one study or another, because it certainly can drastically affect the meaning of the results. Now, I think it's pretty easy to understand that operational definitions are very manipulable, and that this manipulation can sometimes be very misleading. I have a real-life example on the slide here. A manufacturer of aspirin ran a television ad saying, be careful, not all aspirin is alike. Our aspirin is better than the competition. And on the screen of this television ad was at the very bottom a flashing address where viewers of the ad could write to get the details of what made this aspirin better. But the truth is, how many people would actually write to get those details? And what were the details? Well, the manufacturer's aspirin was judged to be superior in several categories, including clarity of labeling of the bottle, accuracy of the count of pills in a supposed 100 pill bottle and the average number of broken tablets contained in each bottle. Things like that, which of course do not have any effect on the actual efficacy of the product. But of course, they were hoping that consumers who viewed this ad would assume that the efficacy of their aspirin was better with their brand. So, pretty misleading, even though they did allow people to write to them to find out what their operational definition of being better was. You're also going to see this in government reports and statistics. For example, one presidential administration improved its civil rights record overnight by redefining what a desegregated school district was. Overnight, their definition went from desegregated, defined as, well, more than half the schools in a particular district being desegregated, to desegregated instead defined as at least one school in the particular district being desegregated. Now, that's a huge substantive difference that really clearly illustrates why it's so important to ferret out operational definitions. And you're going to see this all over the place, like in crime rate reports, economic growth reports, educational achievement of K through 12 students, and on and on. So often you're going to have to work pretty hard to attempt to compare apples to apples if you're looking at research or if you're looking at the effectiveness of, say, two different cities, efforts to drop crime rates. And that is all about operational definition. So I found this really interesting chart on the slide here that has data pulled from the Bureau of Justice Statistics. And this chart shows recidivism rates of U.S. prisoners, recidivism rates of prisoners who were released from prison. And that, of course, reminded me of that prison educational program example in the Monahan and Walker book. So you see on this chart a lot of issues that could end up complicating your ability as a researcher to design this kind of studying a prison educational program, for example. So the chart here shows whether people who were released from prison after being incarcerated for these various categories of crime, whether they were rearrested within 3 years. So that is the operational definition of recidivism the Bureau of Justice Statistics settled on for reporting the data here. Rearrest within 3 years. Now you, as the researcher looking at your prison program, you might also be able to use this 3-year rearrest rate to operationally define recidivism in your prison program study. But you can also see here that there are different recidivism rates for different crimes. So that would be a complicating factor in your research for sure. How do you deal as a researcher with determining overall recidivism increases or decreases when the baseline rates for people convicted of all these different crimes are different? So here, type of crime prisoners were originally convicted of would be one of those extraneous, potentially confounding variables. So you'd probably need and want to report recidivism in your study for each category rather than trying to come up with an overall recidivism rate lumping in all the categories of crime. Again, because of the various differences here in recidivism. Now, there are lots of good examples out there of the importance of operational definition in all kinds of science. I have 3 here on the slide. For example, temperature. Temperature can't be directly observed, right? That has to be operationally defined in some way. And maybe if you're using a mercury thermometer, your operational definition of temperature would be the linear expansion of a mercury column in a glass tube of even width. Or IQ is another good one. IQ can be operationalized using various standardized tests, for example. Age is another one. Age can be the age at your last birthday, or you can break age down by the number of years and months the person is, or in fact, it can just be defined with ranges of age, broader categories like 18 to 25, 26 to 35, 36 to 49, and so on. Here's an interesting one for someone like me who grew up in North Dakota. On this slide, I have just part of the operational definition meteorologists use for wind chill. So I'm sure most of you are familiar with wind chill. That's when air temperature is measured, but then there's this other figure given, including a wind chill factor, which is supposed to tell you what the temperature actually feels like if you're outside in it. So in North Dakota, for example, it's very common for the air temperature in the winter to be 20 below zero. But if you take the wind chill into account, it feels like 50 below zero. So just take a look at some of the things that are actually taken into account by meteorologists here. They calculate the wind speed at an average height of 5 feet off the ground, which not coincidentally is the typical height of a human face, an adult human face. And they also base wind chill, in fact, on a human face model, incorporating modern theories of heat transfer. So how heat is lost from the body to its surroundings on cold days, and then on cold days that are also windy. Obviously, you lose heat faster on a windy day. And so on and so on. There are very particularized ways that they measure this. Okay, so once again, just hammering home this message on operational definition. Remember, it's not about necessarily getting the quote unquote right operational definition, because depending on the purposes of your study, any number of definitions could be valid, any number of definitions could work, right? But the point is that you as a researcher have to be clear on exactly how you are operationally measuring any variable in your study in order to allow others to know what you did and perhaps how to do it themselves to try to replicate it. And the last thing I have on this slide is a little Zen poem for scientists, and the rest of us, I guess. You can manage what you can measure what you can define, and you can define what you understand. So with that, I'm going to end this video lecture number 4.